Have you ever noticed something strange? While working with Python, you install a package in your project, everything works perfectly. Then you open another project and suddenly nothing works. You try to fix it, you install something else, and now the first project stops working. It has same system and same Python, but completely different behavior. At some point, it just feels random, but it is not random at all. There is a clear system behind this, and once you understand the system, this entire confusion disappears. Hi, welcome to Debug Clinic, and in this video, we are going to debug the confusions regarding virtual environment. And we are not just going to show you commands, we are going to explain what is actually happening underneath. We will understand how Python install packages, what pip really does, what dependencies mean, why version conflicts happen, what virtual environment actually are, and how activation works internally. The goal is simple. After this, nothing should feel confusing. Let us start from the beginning. When you install Python on your system, it creates what we call a global environment. Inside this environment, you have your Python interpreter, some built-in libraries, and one very important folder called site packages. Now this folder is where all the external libraries get installed. Whenever you use pip install, everything ends up there. And here is the key detail that most people miss. Every project on your system by default uses this same global location. There is no separation between them. Now let us talk about dependencies properly, because this is where most confusion starts. A dependency is simply any external code that your project needs in order to run. For example, if you write import request, your project depends on the request library, but it does not stop there. That library itself depends on other libraries, and those libraries may depend on even more libraries. So what you are really installing is not just one package. You are installing a chain of dependencies, and this is called a dependency tree. Now, here is where versions become very important. Let us say your project needs request version 2.28. Request internally needs URL lib version 1 point something, and another project needs URL lib version 2 point something. Now, both projects are indirectly fighting over the same dependencies but different versions, and Python cannot satisfy both at the same time in a shared environment. This is what we call a version conflict. And this is why sometimes you install one package and something completely unrelated breaks. It is not happening randomly, it is a dependency resolution failing silently. Now comes pip. First, let us understand what pip actually is. Pip is Python's package installer. In simple terms, it is a tool that lets you install external libraries into your Python environment. For example, when you run pip install request, pip downloads the request library from the internet, specifically from something called Python Package Index or PYPI, which is the central repository where Python packages are hosted, and then it installs it into your system. Now people often assume that pip is handling all this complexity intelligently, but it is not. Pip is actually very simple. It does three basic things. It downloads the package, it installs compatible versions, and it places everything into the site packages folder of your Python. That is it. It does not understand your project, it does not isolate anything, and does not manage environments. It simply works inside whatever environment you give it. So if you are using the global environment, everything gets installed in one shared place. And this is exactly where problems begin. Now combine everything we discussed. You have multiple projects, each with its own dependency tree, each requiring a specific version. But all of them are sharing the same environment. So sooner or later, something has to give. Maybe one project upgrades a library, another project needs an older version, or a dependency deep inside changes. And suddenly, something is going to break. Your code did not change, your logic is correct, but your environment changed. And that is why the error feels so confusing. Because the problem is not in your code, it is in the system around it. Think of it like a kitchen. Not just multiple chefs, but each chef is following a very specific recipe. Each recipe depends on exact ingredients, exact quantities, and the right combinations. Now imagine all of them sharing the same kitchen and constantly changing those ingredients. One chef replaces the oil, another chef changes the spices, and someone else swaps the salt. Even a small change can completely ruin the dish. And now, none of the recipes work as expected. This is how exactly dependencies behave. So, the solution is simple: stop sharing. To resolve this, we have a virtual environment in Python. A virtual environment creates an isolated space for each project. It creates a container for your project so that the libraries you install for one project do not conflict with another. Each project gets its own dependency tree, its own versions, its own installation space, so nothing interferes with anything else. So what actually gets created? When you create a virtual environment, Python creates a folder. Inside that folder, you will find a Python executable, a version of pip tied to that environment, a separate site packages directory, configuration files. It is important to understand this clearly. It is not a completely new Python installation. It is a controlled copy that isolates package storage. Now, before we create a virtual environment, there is one small thing we should quickly check. Do you actually have venv available on your system? In most cases, you already do. You usually do not need to install anything separately. Since Python version 3.3, venv has been part of the standard library. So, if you are using Python 3, it is most likely already available. In Windows and Mac OS, this is straightforward. When you install Python, venv is included by default and you can use it immediately. On Linux, especially distributions like Ubuntu or Debian, things can be slightly different. Some distributions separate venv into a different package to keep the base installation lightweight. So if you try to create an environment and see an error like no module named venv, that simply means it is not installed. In that case, you can install it using sudo apt install python 3 -venv. One thing to keep in mind, it is with hyphen, not without it. Now, here's one more small but important detail here. On Ubuntu and Debian systems, venv is often tied to the specific Python version installed. So if you have multiple versions on your system, you need to make sure you're installing venv for the correct one. For example, if you are using the default Python 3, you can install sudo apt install python 3 -venv. But if you are using Python 3.2 specifically, 3.12, then you should install sudo apt install python 3.12 -venv. This ensures that the virtual environment module matches the Python version you are actually going to use. Once that is ready, we can create the environment. Now, navigate to your project folder in the terminal and run python -m venv.venv. Here, .venv is just a folder name. You can name it anything like venv, env or myenv. But .venv is a common convention because it stays hidden on Unix system. It clearly indicates it's an environment. Templates from platforms like GitHub often ignore it by default. One important rule: never commit your virtual environment to Git because it is large, it is machine specific, and it can be created anytime. From Python 3.13, our .gitignore is automatically created inside the environment folder. In older versions, you need to add it manually in your project by typing .venv \. in .gitignore file. Tools like Visual Studio Code or PyCharm may handle this for you, but always double check your .gitignore file. Also remember, git init does not ignore anything by default. If it's not in .gitignore, it will be tracked. So the correct workflow is push your code, your requirements.txt file, and ignore .venv, cache and temporary files. When someone clones your project, they create their own environment and install dependencies from requirements.txt. That's how clean and lightweight Python projects are shared. After creating a virtual environment, you need to activate it. Otherwise, your system will still use global Python. Activation does not create anything new. It simply changes where your system looks for Python and pip. Before activation, when you type Python, your system is pointing to global Python. After activation, the same command now points to the Python inside your virtual environment. It has same command but different target, and that's what isolates your project. So let us look at common issues people face here while activating the environment. Issue 1. Activation command not working. You run the command and nothing happens, or you get an error. Most of the time, this happens because you are pushing the wrong command for your shell. Different environments use different activation scripts, and this is where many beginners get stuck. In command prompt, you need to run this command .venv /scripts /activate.bat, and here's a simple way to remember this. Windows uses backslashes. You can think of it like backslash is for Bill Gates. Now, if you just type activate or use a PowerShell command here, it will not work because command prompt uses .bat files, not PowerShell scripts. In PowerShell, the command is .venv /scripts /activate.ps1. Here, people often face two problems. Either they use command prompt in PowerShell or they get a security error that we will discuss later. PowerShell uses .ps1 scripts which follow different execution rules. On Mac or Linux, you need to run source.venv /bin/activate. Think of it like the / is for the file system on Linux, and if you try using Windows style path like scripts, like we have in PowerShell, it will fail because Unix based system use a completely different folder structure, OS bin instead of scripts. Issue 2. Common errors that you might see. Let's look at what people usually encounter. No such file or directory. This usually means you are not inside the correct project folder or the virtual environment was not created properly. To fix this, make sure .venv folder exists and you are in the right directory. Activate is not recognized. This happens because you are just typing activate instead of the full path or using the wrong shell command. To fix this, always use the correct path. Permission denied in Mac or Linux. This means the script does not have execute permission. To fix this, you can run the following command on Linux server. Nothing happens after running command. Sometimes there is no error but no change. To fix this, look carefully at your terminal. If you see something like .venv in brackets at the beginning in your terminal, that means it actually worked. Your environment is activated, and if it's not there, you need to activate it again. Issue 3. PowerShell running scripts is disabled. If you are using PowerShell, you might see a red error like running scripts is disabled on this system. This happens because of a Windows security setting called execution policy. By default, PowerShell blocks scripts like activate.ps1. To fix this, you need to allow local scripts to run. You can do that using this following command. This allows scripts created on your system to run while still keeping security in place for downloaded files. You only need to do this once in your system. Issue 4. Python is not recognized. Even after activation, you type Python and it says not recognized. This usually means Python is not added to your system path or the environment was not activated properly. To fix this, reinstall Python with add to path enabled or deactivate and activate the environment again. So remember this clearly. Activation does not create anything new. It simply redirects your commands. It is not failing randomly. Most of the time, it is just the wrong command, wrong shell, or wrong path. Once you understand that, most of these errors become very easy. Once your environment is activated, this is where things finally start making sense. When you install packages now, they go into this isolated environment, not into a global environment. So each project builds its own dependency tree independently. Different versions, different libraries, and no interference. And this is exactly where those random version conflicts disappear. Another common issue people face is installing in wrong environment. Sometimes people open a terminal, forget to activate the environment, and install packages globally by mistake. So always check .venv in the terminal. If yes, you are safe. If not, you are installing globally. Now once you are done working, you can deactivate the environment. Just type deactivate in your terminal. This takes you back to your global Python. Nothing gets deleted, nothing breaks. It just switches your context back. And the next time you work on the project, you simply activate it again. So think of it like switching workspaces. Activate, you enter your project's world. Deactivate, you return to the system world. You remember that kitchen example? Where everything was breaking because everyone shared the same space. Now imagine, each project has its own kitchen. That's what virtual environments do. Things stop feeling random now. You stop guessing the errors and start resolving them. In the next video, we will cover issues like dependency install errors, system versus user Python, pip versus conda, and VS Code confusion. Most developers struggle not because of code, but because they don't understand the environment. So let's fix that. I'll see you there in the next one.